This is the innovative and versatile pneumatic multiplier, the J gun. The J stands for Jetide, the HYTORC division that handles advanced bolting solutions. It is operated by air rather than hydraulics, offering greater range of movement and flexibility in many bolting applications. Unlike an impact wrench that produces unregulated force, the J gun is an automated torque multiplier which delivers measured and consistent torque on every bolt, combining both precision and power. Torque output is controlled by carefully metering the air pressure supplied to the tool. The direction of the tool, whether tightening or loosening, is set with the flick of a switch, while the trigger provides instant start and stop control. J guns come in both single and dual speed models, in a range of sizes and power ratings. The tools are numbered according to their maximum torque output in thousands of foot-pounds. For example, the J.5 will produce up to 500 foot-pounds, about 625 Newton-meters, of measured adjustable torque. The J1 is capable of approximately 1,000 foot-pounds. The J3 delivers more than 3,000 foot-pounds, and the J5 has a maximum torque of over 5,000 foot-pounds. The dual-speed model shifts easily from high speed for fast rundown to high power for accurate torque and back again by shifting the side leverage handle. For standard nuts and bolts, a reaction arm steadies the tool. But the J gun is also fully capable of the advantages of the load disc because of its unique, splined concentric drive design. Before we begin, because we will be handling high-pressure air and heavy and sometimes sharp metal implements, we should first put on our personal protective equipment. At a minimum, this should include safety glasses with side shields, sturdy gloves, and steel-toed shoes. Of course, job conditions and local work rules may require other safety items such as hearing protection, face shields, hard hats, and fire or chemical-resistant clothing. Nothing is as important or as urgent as your safety. Let's see how the J gun system connects. Check the condition of the hoses, connectors, and the general condition of the air regulator and tools for any obvious damage. Any defects must be corrected before pressurizing the system. For optimum performance, the J gun requires a clean, dry air supply of 30 cubic feet per minute at 90 pounds per square inch. The supply hose should be connected to the input side of the pressure regulator assembly with any connector compatible with your air system. Connect the J gun's air hose to the output side of the regulator and snap on the J gun with a quick disconnect coupler. The air control assembly, or FRL, consists of a filter, a pressure regulator, and a lubricator. Do not operate the J gun without this FRL unit in the airline, as serious damage to the tool will result. The job of the filter is to remove any debris or water from the air supply. The filter can be drained as needed with the valve on the bottom. The regulator meters input air pressure accurately, controlling the torque output of the tool. The lubricator's job is to introduce a fine mist of oil into the airstream to lubricate and protect the internal parts of the tool against corrosion or damage. Depress the detent and twist the clear plastic reservoir to remove it. Fill it to the indicator mark with a quality air tool oil. With air flowing to the tool, you will be able to see drops of oil form inside the clear plastic knob on top of the lubricator. Unscrewing this knob increases the oil flow, and screwing it in decreases the oil drops. Adjust the flow to approximately 1 drop every 10 seconds. In the high-speed mode, the J gun rotates at several hundred revolutions per minute, while torque is limited so that the tool cannot spin or kick back in the operator's hands. Before we can torque, the tool must be shifted to the low-speed power mode. The reaction arm will not attach until this shift is done, ensuring that it cannot spin at high speed. As a matter of fact, the reaction arm will not spin at all as long as the socket is free to turn. Now let's put the system into action. Let's suppose that the job at hand is to tighten these 4 1¼ studs with 2-inch nuts to 600 foot-pounds of torque using the dual-speed J3. It is not our purpose here to discuss how torque values are determined. Click on the additional training icon in the table of contents for help in computing torque values or obtaining additional instruction on bolting principles. Since the turning force of the tool is determined by the air pressure supplied, we must consult the pressure-torque conversion chart for our specific tool to find out how much pressure to apply. In this case, we are using the dual-speed J3. Looking down the foot-pound column, we find 600 foot-pounds corresponds to 30 psi. With the tool on a stable surface, turn on the air supply and adjust the incoming air pressure upwards to 30 psi by turning the regulator knob. With the tool in the high-speed mode, that is with the reaction arm removed, we are ready to run down all the nuts. The studs and nuts should be clean and free-running before any turning force is applied. By the way, only high-grade impact sockets should be used with the J-gun. Never use chrome or manual-grade sockets as they could shatter, causing serious injury. Never use an oversized socket, as this can be dangerous. Always pin the socket onto the drive. With the directional switch in the tightening position and holding the tool securely with both hands, quickly run the nuts down until snug. Remove the socket, shift the tool to the low-speed power mode, snap the reaction arm into place, and replace and pin the socket. Engage the nut, turn on the tool, and observe the reaction arm turn until it butts up against the next nut. You can speed the work by pre-positioning the arm rather than waiting for it to turn. Never touch the reaction arm or the reaction surfaces while the tool is running. Hold the trigger in until the tool stalls and will no longer advance the socket. You have applied 600 foot-pounds of torque to that nut, and every nut will get the same tightening force until you change the pressure on the regulator. Note, your bolting plan may require tightening in increasing steps. If that is the case, simply adjust the air pressure accordingly for each step. It is always a good practice to make a final check pass on all nuts because tightening one may change the achieved load in its neighbor. To remove the nuts, reverse the process, this time beginning in low-speed power mode with the reaction arm in place. The effects of time and corrosion can make nuts or bolts more difficult to remove than they were to tighten. Since we don't care about achieving a specific torque value, turn up the air pressure to at or near its maximum, giving the tool its full power. Shift the directional control to the loosened side. Apply the wrench and position the reaction arm against the next nut, keeping in mind that the arm will now move clockwise, opposite the direction of the socket. Loosen all the nuts until they can be turned by hand. Remove the reaction arm and shift the tool into high speed and proceed to run off the nuts. The same process and steps apply when using the load disc and driver, except that there is no need to remove or reapply the reaction arm. With the dual drive socket in place, the wrench can be speedily shifted from run down to torquing to run off, all without any danger of pinch points or needing a backup wrench to hold the opposite nut.